In Chapter 1, we're looking at some basic ideas of statistics. This first section is going to be about sampling. And that means how we're collecting data. And that's the whole idea behind statistics, is the study of procedures for collecting, describing, and drawing conclusions from information. And that's used in every type of career. So the two things we want to think about first is that when we talk about collecting data, usually we're looking at a population, the entire collection of individuals about which information we want to know. And it might be all of the adults in the U.S., but we really can't collect data from everybody. So we usually collect a sample of that population to collect the data from. A parameter is the numerical measurement that's describing the population. A statistic is the actual measurement that we get from the sample. So knowing the difference between those two terminologies is very important. So let's first look at the first example. And this is about state elections. The comptroller of Texas wants to know how she will do in the upcoming state election. She hires a consulting firm, and they polled 3,000, that should be a comma, 150 registered voters. The consulting firm finds that 57% of the polled voters will vote for her. It turns out that after the election, she wins with 60% of the vote. So which one of those would be a parameter and which one would be a statistic? So a statistic is collected from a sample. So the statistic comes from the sample. So that would be from when she got the poll. So the statistic would be the 57%. But the parameter would be the outcome from the actual election. That's coming from the entire population of the state of Texas. Now let's see if we can identify what the population and what the sample of each study is. So the Gallup organization contacts 1,028 teenagers who are 13 to 17 years old and live in the United States, and asks whether or not they have been prescribed medication for any mental disorders such as depression or anxiety. So sometimes it's easier to start with the sample. Well, the sample are the 1,028 teenagers contact teenagers. Between 13 to 17 contacted in the U.S. So what is the population we're looking at? Are we looking at all adults? No. Are we looking at all teenagers across the entire world? No, we're looking at U.S. teenagers age 13 to 17. If our sample doesn't include any 12-year-olds, then we can't be including them in the population. A quality control manager randomly selects 50 bottles of Coca-Cola that were filled on October 15th to assess the calibration of the filling machine. So my sample are the 50 bottles of Coke randomly selected on October 15th. What is the population that we're trying to analyze? Is it all Coke bottles manufactured forever? No, it's the bottles of Coke filled on October 15th. A farmer wanted to learn about the weight of his soybean crop. He randomly sampled 100 plants and weighed the soybeans on each plant. Well, this one's a little bit easier. The sample are the soybeans from 100 plants. The population, now be careful here, it's not all soybean plants, it's just the soybean, whoops, I can't spell, soybean plants from his crops. Every year, the U.S. Census Bureau releases the current population report based on a survey of 50,000 households. The goal of this report is to learn the demographic characteristics of all households within the U.S., such as income. So they basically give this one to us. The sample is the 50,000 households surveyed. In the U.S. and the population are all households in the U.S. A large community college has noticed that an increasing number of full-time students are working while attending the school. The administration randomly selects 128 students and asks this question: how many hours per week do you work? So the sample are the 128 college students randomly selected. And the population are all students at that community college. Be careful not to say that it's all students at every community college, because they didn't ask students at just any community college. They asked students at that community college. All right, let me change pages. Now, parameter, population, statistic goes with sample. So following the 2006 national midterm election, 18% of the governors of the 50 United States were female. Is this a parameter or a statistic? Well, it's talking about all states, so that's a parameter. The average score for a class of 28 students taking a calculus midterm exam was 72%. Now be careful. If our population is that class, then this is a parameter. But what if our population are all calculus classes for that school? Then this would just be a sample. So this could be either. It depends on the population. So it depends on what you set your population as to whether the data you're looking at would be from the population or a sample. In a national survey, key point says survey, of high school students grades 9 to 12, 25% of the respondents reported blah, 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 the keyword survey. That means we took a sample. That automatically means this is a statistic. In a national keyword survey, that means this is a statistic. Ty Cobb is one of Major League Baseball's greatest hitters of all time, with a career batting average of 0.366. Is this a parameter or a statistic? Well, this is just data from one person. This is just a statistic. It's not an entire population. Only 12 men have walked on the moon. The average age of these men at the time of their moonwalks was, so only 12 men. So that's the entire group. That's a parameter. A study of 6,076 adults in public restrooms found that 23% did not wash their hands. That's disgusting. But it's a study. A study. A survey. That's a sample. That means this is a statistic. Telephone interviews of 1,502 adults. Telephone interviews. That means we're sampling. That means this is a statistic. Notice that keywords can clue you in onto what you're looking at. Now, the last thing we're going to look at in this lesson are the different ways we can collect a sample. And the main ones we're going to look at are these 6. A simple random sample is a sample collected where every population is equally likely to make up the sample. It is truly random. Maybe you use a random number generator. Maybe it's a true drawing of names out of a hat or something like that. But it's truly random. Sample of convenience. It's not drawn by a well-defined random method. It's more like I stand at the door and just hand out surveys to the first 5 people that walk in. I'm being lazy. I consider a sample of convenience being just really lazy. Stratified and cluster tend to get confusing. So let's think about these two. Stratified. The population is divided into groups. And then a simple random sample is taken from each group. I think of this one, say I take a high school, and that population is already divided into grade levels, freshmen, sophomores, juniors, seniors. And then I take a sample from each group. Each group is sampled. A sample from each group. A cluster sampling is if I divide the whole population up into clusters and then whole clusters are selected. Let's take that high school example again. This time, let's take everybody's homeroom class, and I'm going to select Miss Jones' homeroom class, Mr. Thomas's homeroom class, and Miss Smith's. Oh, they could have a mix of 9th, 10th, and 11th. I don't know what grade they're in, but I'm selecting the whole homeroom class. So it's a whole cluster. Systematic is the easiest to spot. This one is where you order the population. Maybe you put them in alphabetical order. Maybe you put them in order by their ID number. And then each CAIF element, that's a weird number to say, but maybe I pick the fourth person on the list. Every fourth person. So I go 1, 2, 3, that one. 1, 2, 3, that one. 1, 2, 3, that one. So when they're selecting every something person, that's systematic. Voluntary response is just that. You let people choose whether they want to respond. So, taxpayers in a population are listed in order of increasing income. A sample is selected by first separating the taxpayers into 4 groups based on income, and then randomly selecting 50 people from each group. From each group is stratified. Each group is going to be equally represented. A sample is selected by randomly choosing one of the first 100 names, then choosing every 100th name from that point forward. That's going to definitely be systematic. A random number generator is used. That's a simple random sample. A sample is selected by first separating the taxpayers into 4 groups and then selecting all members in 2 of the groups. That's a cluster. We're selecting a whole cluster. Now let's see if we can identify them in the next ones. And I invite you to try these, pause the video, and then come back and see if you get them right. To estimate the percentage of defects in a recent manufacturing batch, a quality control manager at Intel selects every 8th chip. Every 8th. That's systematic. To determine the prevalence of human growth hormone use among high school varsity baseball players, the State Athletic Commission randomly selects 50 high schools. All members of the selected high school's varsity baseball teams are tested. All of the members are tested. A member of Congress wishes to determine her constituents' I can't say that word, opinion regarding estate taxes. She divides her constituency into 3 income classes: low income, middle income, and upper income. She then takes a simple random sample from each. That would be stratified. In an effort to identify if an advertising campaign has been effective, a marketing firm conducts a nationwide poll by randomly selecting individuals from a list of known users of the product. They're selecting people they already know use the product? That's convenience. Not even trying to go out and find anybody else. First, divide the country into primary sampling units based on size and population. Then sample from each PSU and divide those into ultimate sampling units. Finally, random sampling from each of those. That's double stratified. A farmer divides his orchard into 50 subsections, randomly selects 4 and samples all the trees within those 4. That's a cluster. A school official divides the student population to 5 classes: freshman, sophomore, junior, senior, and graduate student. The official takes a simple random sample from each class. That's stratified.